So in this video, we're going to be looking at solving a quadratic by square roots. Now, I've already uploaded a video that covers solving a quadratic by factoring, and I've also looked at or uploaded a video looking at simplifying radicals. I would make sure to go look at those before you cover this. But what we're going to look at mainly first is the format that we're going to have for these type of problems. So here's what the format's going to look like. Ax squared plus c equals 0. Or, I mean, a couple things could be moved, but this is the basic setup. All right, now, when we have this setup, essentially here's what we can do. We can say if x squared is equal to n, and n is just a number, and we can say we can solve this or get rid of this exponent 2 by square rooting both sides, which would give me x equals plus or minus the square root of n. So that's essentially how we're going to solve this type of setup for a quadratic. Now, I do want to also make this note. Notice that there's no bx term here. That's basically what we're looking for. So the bx term is missing. So when that bx term is missing and it basically goes x squared plus a number, that's when we're going to use this, can use this format or method. So let's start with a problem. Let's say I have x squared minus 64 equals 0. Now, I could technically factor this. I could factor this left side by difference of squares. But instead of doing that, let's just see if we can do it with square roots. So the first thing we want to do is isolate this x squared. So we want to get x squared by itself, which means this minus 64 needs to move to the right. So hopefully we remember we could move that by adding 64. So x squared is equal to 64. Now, once again, if we want to get rid of this exponent 2, we can square root both sides. We just have to remember that when we do that, we have to take the square root of 64, but we have to add and subtract. So we have to say plus or minus the square root of 64, which is 8. So in this case, x is equal to positive 8 and negative 8. All right? So we can also cover this. Here's why we need the plus or minus. Because this is x squared, let's just say I plug in x as 8. 8 squared minus 64 would equal 0, so that checks out. But then the reason we need the negative is because if we're squaring something, the negative version of this answer would also work. We could say negative 8 squared minus 64. That would also be 64 minus 64, so that would check out. All right, so now let's go to another example. Let's say we have 7x squared plus 8 equals 15. So now once again, we notice that our bx term is missing, so what we can do is isolate x squared. So we can subtract 8. We can say 7x squared equals 7. So now we can continue to isolate x squared and divide by 7. So x squared equals 1. And now we need to get rid of the exponent 2 by doing this opposite, which is the square root of both sides. So we're going to say x is equal to plus or minus the square root of 1, which is just 1. All right, let's do another example, because we're going to start getting into examples where you can't necessarily break down the radical. But let's look at one more that you might see, and then we'll start breaking down some radicals. Let's say I have 81 squared plus 5 equals 21. Now, once again, we want to isolate x squared. So we're going to subtract 5. Then we have 81x squared equals 16. Now, this step seems a little odd, but we're going to continue to isolate x squared by getting rid of 81. Now, what we don't want to do here, we want to make sure that we pay attention to our fraction. If our fraction has a top and a bottom that are perfect squares, we want to keep that fraction exactly like it looks, because when I get rid of this exponent 2 and I square root both sides, when I square root a fraction, I actually square root the tops. So we would say x equals plus or minus. We would square root the top and divide that by the square root of the bottom. So once again, we do the square root of 16 over the square root of 81, which will give us plus or minus 4 over 9. All right, so that would end up being our answer. So let's look at another one real fast. Then we can look at breaking down a square root. So 9x squared plus 3 equals 111. So here's our job. Our job is to, once again, notice that bx is missing, and then we're going to try to isolate x squared, because we can use square roots for this. So first we're going to add or subtract, so we're going to subtract 3. 9x squared is going to equal 108. And now we're going to come back and isolate x squared even further by dividing by 9. So x squared equals 108 divided by 9 is going to give me 12. Now, that seems a little odd because hopefully you're looking ahead and saying, well, when I square root both sides, I can't do the square root of 12. But let's go one step at a time, and I'll show you how to handle that. So to get rid of this exponent 2, once again, we're going to square root both sides. And we're going to say x is equal to plus or minus the square root of 12. Now, once again, if you were to just plug in the square root of 12 in the calculator, it's going to give you a decimal. And sometimes we don't want the decimal, we want the exact number. So we don't want to do any rounding. We want to just break down this radical. So remember, if we want to break down a radical that's not a perfect square, we're going to try to find the biggest perfect square that divides 12, and that would be 4. So then we can break down this radical and say the square root of 4 times the square root of 3. So then we can say x is equal to plus or minus the square root of 4 is 2, but then the square root of 3 can't be broken down any further, so we just leave it the square root of 3. So in this case, our answer would be x is equal to plus or minus 2 radical 3. Let's do one more of those. And pretty much as always, I would be pausing and practicing these if I were you, just so you can get the hang of it. But let's say, let me find a good one. Let's do 4 minus 3x squared equals negative 77. Now this setup looks a little odd, but we can actually use the same method to solve this setup, because once again, there's no bx term. If there's no bx term, you can essentially use the square roots method. So once again, we're isolating x squared, so we want to get rid of this plus 4 by subtracting 4. So the negative 3x squared, actually, let me go back, minus 4, there we go. All right, so negative 3x squared is going to equal negative 81. Now, we're going to continue to isolate this by getting rid of negative 3 and dividing negative 3. So then x squared is going to equal 27. So now, when we square root both sides, to solve this, we're going to have to break down this radical. Because if I do plus or minus the square root of 27, the square root of 27 could be broken down further, and that's typically how you'll see your answer choices. So once again, I want to break this down by saying what is the biggest number that's a perfect square that divides 27, and that would be 9. So then we can rewrite this, the square root of 9 times the square root of 3, so x is equal to plus or minus the square root of 9 brings out a 3, and then the square root of 3 stays on the inside. So once again, that's how we can solve a quadratic using square roots. It's a very useful trick, and once you get really good at it, it becomes pretty efficient and pretty quick to actually perform.